Gamma ray bursts, or GRBs, are the most energetic events in the universe. They are hundreds of times more powerful than a supernova, typically last about a minute, and briefly outshine the rest of the gamma ray universe. GRBs are divided into two categories, long and short. Long GRBs last from several seconds to many minutes and are caused by the deaths of massive stars. Short GRBs last less than 2 seconds, down to milliseconds. They are thought to result from mergers of compact, ultra-dense objects like neutron stars and black holes. Long GRBs make up most of the observed gamma ray bursts. When a star born with more than 30 times our Sun's mass runs out of fuel, the core quickly collapses into a black hole. As surrounding material falls toward the black hole, some of it forms narrow, intense jets of particles that drive through the star at 99.9% the speed of light. The jets burst through the star on opposite sides and keep speeding into space. These jets produce gamma rays when they first emerge, and light across the spectrum as they interact with gas and dust surrounding the star. If a jet is pointed in our direction, spacecraft instruments can spot the bright gamma ray flash. Other telescopes that detect different kinds of light can then follow up by observing the burst's long afterglow, from X-rays to radio waves, with each type of light giving astronomers different information about the burst. Short gamma ray bursts likewise produce narrow particle jets following the abrupt formation of a black hole. In this case, however, the black hole forms when two city-size objects, each weighing more than the Sun, spiral toward each other and merge. These objects can either be neutron stars or black holes, both the ultra-dense remnants of supernovae. These brief events are also followed by a long fading afterglow and other phenomena. The systems that create short gamma ray bursts also produce gravitational waves. In 2017, such waves were detected 1.7 seconds before a short GRB appeared in the same direction. A first that conclusively proved that neutron star mergers can generate short GRBs. But some events share characteristics with both short and long gamma ray bursts. One of the many mysteries scientists are still trying to solve. Despite being the brightest events in the gamma ray sky, occasionally even temporarily blinding satellites, all the GRBs ever detected erupted over 100 million light-years away. These bursts emit more energy than our Sun will produce over its 10 billion-year life. They truly are the biggest light shows in the universe.